Hello and welcome back to the Ways of Math. I'm your host, Dan the Math Man, and today we're going to continue our series on Introduction to Sets. This is part 10, and this is the final part of the core idea behind the introduction of sets. So before we begin, please be sure to subscribe to the channel to be notified of future videos, and hit that like button if you like this video. And always, please leave comments or suggestions in the box below if you have any. Today in the video, we're going to continue this applications of sets. Right, so we're finally seeing the fruit of our labors from all the abstraction that we've done with sets, and now let's get to see how we tackle real problems using sets. So the examples today is going to be an example involving a set related question with 3 sets. So it's an example of using 3 sets to solve a problem. Okay. So here we go. A high school student working for the school paper wanted to determine what the favorite subjects of the school's students are. So he thought a survey would help. The following are the results of his survey. So a total of 481 students took the survey. Of those, 213 said they liked science, 261 said they liked English literature, 179 said they liked mathematics. Again, of all of these, 71 said they liked science and English, 109 said they liked science and math, 43 said they liked English literature and mathematics, 39 said they liked all 3 subjects. Okay, so keep in mind, the information here isn't necessarily disjoint, right? So some of the people that like science are going to be in this category of those who like science and English literature. And those that like science are also going to be in the category of those that like science and mathematics, right? So we don't have any way of differentiating specifically what goes into each individual region, right? So this is where sets are helpful, and particular Venn diagrams are going to help us organize all of the information here so that we can answer some questions. And here are the questions. Using the Venn diagram, we want to answer the following questions. How many students like none of these 3 classes? How many of the students like exactly 1 of these classes? How many of the students like either science or mathematics? Notice or emphasized here. How many students like mathematics and science, but not English literature? Again, and not emphasized here. Keep those in mind for later. Also, how many students like English literature or science, but not math? Keep in mind the or and the not. And finally, how many students like exactly 2 of these classes? Not just 1, and not all 3. Exactly 2 of the classes. So to make sense of all this, we're going to set up a Venn diagram. Now suppose our sets we're going to define as the set of students who like science, a set of students who like English, and a set of students who like math. Again, just like in the previous example from the previous video, it doesn't matter the specific elements because all the elements are students. What matters is their responses on the survey. So how many of them responded a certain way on the survey. So again, we're going to construct our Venn diagram dealing with the cardinalities of each of the 8 regions of this. Okay, and again, I have all of our information up here from the survey, and so we can begin. Remember, we always start from the innermost the region with the most amount of overlaps. So the region where all 3 sets overlap. So region 5 here. So region 5 corresponds to those who like math, science, and English literature. So it's in the intersection of all 3 of those. Well, that's in fact given from the problem. 39 said they liked all 3 subjects. So we know that in region 5 there are 39 students. Okay. Beginning our spiral outward to fill this, we now move on to region 2. So these are the students that like science and English, but not necessarily mathematics. So they're disjoint from these students that like all 3. Well, we don't know explicitly who likes only science and English, but we do know how many like science and English. In fact, 71 said they liked science and English. So we know that these two regions, 2 and 4, correspond to the number of students that like science and English. So their sum of their cardinalities have to be 71, because we know there were 71 responses that liked science and English. Well, since we already know that there are 39 students in region 5, we subtract 39 from the 71 to get how many are in region 2 here. So 71 minus 39 gives us 32. That goes in region 2 there. Continuing our spiral, working our way to region 4 here. Okay, so the students that like science and math, but are outside of English. Okay, so again, we know how many students like science and math. Okay, in fact, 109 said they like science and mathematics. Remember, we've already counted 39 students that like all three. So if we want to know how many like only science and mathematics, we need to subtract the 39 we know from the 109 total students. Okay? Because remember, the sum of these two cardinalities have to equal the cardinality of the intersection of science and math, which are these two regions. So 109 minus the 39 is equal to 70. So there are 70 students that like only science and math. So that's 70 students in region 4. Now we move on to region 6. Okay, so we want to know how many students like math and English only. Okay, so again, we know how many like English and math, which is 43 students said they liked English literature and mathematics. So remember that English and math correspond to regions 5 and 6. So the cardinalities, the sum of these cardinalities have to be 43. So we take the 43 that we know, subtract the 39 that we already have, and we get 4. So there's in fact 4 students in this region 6 here. Spiraling out yet again, moving on to region 1. So here we want to know how many students like only science. Well, what do we know about science? We know that there are 213 respondents that like science. But the region of science, okay, the regions involved in the set science is regions 1, 2, 4, and 5. We've already accounted for regions 2, 4, and 5. So we know that the sum of the cardinality of 1 plus the cardinality of 2 plus the cardinality of 4 plus the cardinality of 5 have to equal the 213 students. So therefore, we need to subtract the known regions to get the missing region. So we take our 213, subtract region 5, which is 39, subtract region 2, which is 32, and subtract region 4, which is 70. This gives us a total of 72 students like only science. So region 1 has 72 students in it. Moving on to region 3, by the similar method, we know that 261 students said they liked English. And again, the set of English students that liked English consists of regions 2, 3, 5, and 6. So in order to get region 3, we need to subtract what we already know from regions 2, 5, and 6 from the total number of students that said they liked English. So we have 261 minus region 5, which is 39, minus region 2, which is 32, minus region 6, which is 4. And that results in 186 students liked only English. And now another region, moving on to 7, okay, in very like fashion, is the number of students that liked only math. Well, we know that 179 respondents said they liked mathematics. And again, mathematics consists of the regions 4, 5, 6, and 7. So we know that the sum of all 4 of these has to give us 179. So to get the missing region, 7, we need to subtract what we know from the 179 to get region 7. So we take the 179 minus region 5, which is 39, minus region 4, which is 70, minus region 6, which is 4, we get 66 students in region 7. And now finally, to get region 8, we take the cardinality of the universal set, which is all of the students that took the survey, 481, and we subtract all of the regions. This is the number of students that didn't say that they liked science, English, or mathematics. Okay, 481 took the survey, but not necessarily all of them liked any one of these regions. And that's what we're trying to find out. So we take the 481 and subtract all of the regions. So 481 minus 72 minus 32 minus 186 minus 70 minus 39 minus 4 minus 66, and the result is 12. There are 12 students here in region 8. So now we have our completed Venn diagram, so we can now tackle the questions. Question 1 says, how many students liked none of these classes? Well, the students that liked none of the classes correspond to region 8. We already talked about that. So region 8 with the number of students that didn't like any of the classes. So as we see shaded here, region 8 consists of the cardinality of 12. So there were 12 students that took the survey that didn't say they liked any of the classes. So our answer there is 12. Question 2, how many students like exactly one of these classes? Okay, so be careful with the wording here. We want exactly one. Okay, so there are no overlapping. So we consider only those regions consisting of exactly one set. So no overlapping, because otherwise that would be an intersection of sets. So we want exactly one. Well, this corresponds to regions 1, 3, and 7, right? These are students who liked only science, students who liked only English, and students who liked only math. We want to know how many students liked exactly one class, so we add up all 3 of these regions, 72 plus 186 plus 66, and we get that 324 students liked only one of these classes. Question 3 asks, how many students like science or mathematics? Remember, this or, so or corresponds to the union. So we want to know how many students are in the science or math, or namely the science union mathematics. So we take all of the regions of science in union with all the regions in mathematics. So science is 1, 2, 4, and 5. Math is 4, 5, 6, and 7. Putting them all together to get the union, we get all of these regions here shaded. So we need to add up all of these students to figure out how many liked either science or mathematics. So adding up 72 plus 32 plus 70 plus 39 plus 4 plus 66 yields 283 students liked either science or mathematics. Question 3. How many students like mathematics and science, but not English literature? So, again, the key words and not. So mathematics and science implies the intersection of mathematics and science, right? So the intersection of math and science is regions 4 and 5. But not English literature means the complement of English literature. So we want to be outside of the English set, this red set here. So what's in region 4 and 5, but outside of the red set English? Well, that's only region 4. So the answer to how many students liked mathematics and science, but not English literature, is 70. There were 70 students. How many students like English literature or science, but not mathematics? Careful with the key words. This one is or and not. So English literature or science is the union between English literature and science. So how many students are in the union of English and science, but not in mathematics. Well, the union of English and science is regions 1, 2, 3, 4, 5, and 6. But we want to be outside, so we want to be in the complement of mathematics. So that's outside of that, so we get rid of these 3 sets, 4, 5, and 6, because they're contained in math. And this leaves us with region 1, 2, and 3. Summing up 72 plus 32 plus 186 is a total of 290 students that liked either English literature or science, but not mathematics. Again, we're starting to see, hopefully, much more clearly than when we started this series, just the power of sets and specifically the power of Venn diagrams for organizing all the information so that we can fairly easily answer the questions once we know exactly what they're asking. Question 6. How many students like exactly 2 classes? Right, so in this final question, we want to only consider those regions that are the intersection of exactly 2 sets. So not just one set by itself, not all 3 sets, but exactly 2 sets. So we're looking for those that are in science and English, but outside of math, in science and mathematics, but outside of English, and those that are in English and math, but outside of science. So they only like 2 of the 3. Well, that's going to be region 2 here, right? Because science and English intersect here, but it's outside of math. So there's only 2 sets intersecting in this region 2 here. Similarly, region 6 is intersection of math and English, right, but not science. So there's only 2 sets intersecting here. These are the students that like exactly English and math. Also in region 4 is again an intersection of exactly 2 sets, science and math, but it's outside of English. So these are the students that like exactly science and math. So we want to, again, to answer our question, take the sum of all 3 of these in the shaded regions. So we add 32 plus 70 plus 4. We get a total of 106 students like exactly 2 classes. Okay? So, final thoughts on this. We see, again, the power of mathematics to solve application problems, as long as we know how to properly organize our information, as we do with a Venn diagram, and how to properly interpret information, looking for those key words to interpret the mathematics, we can solve problems much easier. Thanks for watching this video. Please be sure to subscribe, and please leave any comments or suggestions in the comment box below. I hope you liked this video, and as always, have a wonderful math-filled day.